Hi all, I'm Nat and welcome to Webinars. Every Thursday, we do fun talks and discussions on neuroscience and neurodiversity, taking a deep dive. The key aim to these workshops were originally for neurodivergent individuals to better understand their brain. Typically, you're neurodivergent, have a good day. No one really tells you what it means. So we have been taking deep subjects and breaking them apart. And today we are looking at the history of neuroscience. We have looked at the history of autism, dyslexia, dyspraxia before, but that's like recent history. We're going to turn back the clock and go right to the very beginning. What were cavemen doing with our brains? What were the Egyptians? What were the Greeks? How have we developed in the 20th century? It's an interesting journey, and you will realize that we have known about conditions like autism in some way for quite some time now. And interestingly, things like schizophrenia or epilepsy were some of the first to be discovered or at least coined. Just so you know, most of our webinars do predominantly focus on neurodiversity. These are neurological or neurodevelopmental conditions such as dyslexia, dyspraxia, autism, ADHD. Now, today, we are not focusing on this, but it still fits into the wider theme of everything about how we understand our brain. Going back in time, obviously, autism, dyslexia, dyspraxia were not a diagnosed thing, but it definitely was still a thing. We just didn't know about it. So how did people deal with this? What did they use for support? Mental health support back in the day was rough. And if you like a bit of horrible history, we're going to be talking a bit about that today as well. I'm a sucker for the blood and gore. I'm just so glad I don't live in that time anymore. Though some of the practices we're discussing, they still do use. Here's me. So just so you know, I am a neurodivergent specialist. Essentially, I talk about the brain every single day. I'm just finishing up my master's in neuroscience as we speak. I'm also supporting neurodivergent individuals. I'm neurodiverse myself, so I have dyslexia, dyspraxia, and autism, which hopefully gives a little bit more of a unique spin on this. And I do a lot of other things as well. You're in good hands. If any of you have questions related to anything today, please feel free to ask. I'll do my absolute best to answer. And if not, I'll certainly find out the information. Here is our team with brand new photos. So today we've got myself. Now, I got rid of the one with the Cobra Kai t-shirt because it made me look like a 13-year-old, even though this photo is like 10 years younger. But we've got Izzy, who's new on our team, who now has a photo, and April. There's no reason why some of us in black and white and not, I just thought I'd look a bit more creative. Last week's webinar we did on what is metacognition? If you remember correctly, it's about thinking. How do you, that kind of self-awareness, that self-consciousness? And also we looked about how does that relate to autism and neurodevelopmental conditions? It was a really fascinating one. And I just loved looking about at what age, when do we know that we are alive? And looking at other things, like for instance, if you put an elephant in front of a mirror, it may wave to itself with its trunk. You put a dog in the mirror, it's going to bark at it because it has no idea that it is a dog. So different levels of intelligence has different self-awareness. And currently, elephants and monkeys are smarter than a 4-year-old. Fair enough. But then we overtake them later on. So really interesting. Do check out our YouTube if you're interested in learning a bit about metacognition or learning about thinking. The history of neuroscience. So I'm going to give you the highlights, my favorite bits from the last 5,000 or so years. So the top things we're going to be covering is the scope. What even is neuroscience? Where does it start? Where does it end? For instance, where is the brain? Not an easy question. You think it's up here, but actually you've got your spinal cord here and the brain goes a little bit down and then you've got all your neurons and your connections. Where does it start and where does it end? We're also going to be looking at early brain studies. Why were we drilling holes in our heads? What do we think we're going to accomplish by doing that? And why do some people still put holes in their heads? We're going to look at some key discoveries. What were some moments in time that were absolute game changers? And if appropriate, we're going to be circling back to neurodiversity and how it relates to neurodevelopmental conditions. And we're also going to be looking at the future. What do we have to be excited about? Where are we heading? My first question to everyone is, what is neuroscience? Might seem like a simple question, but it's a good one to ask. Where does it start? What is the scope? What do we mean by neuro? What is even science? All right, we've got the study of brain development. while that is absolutely part of it, is there more to it than meets the eye? How the brain works? Yep. How it's ticking, what's going under the old hood? The study of the brain function and form, yes, that gives a little bit more encompassing. It's including a bit more. Science relating to the brain and nerves, yes, I like that you mentioned nerves. Nerves are a big part of this. Let's just not, the brain doesn't work on its own. It's just a big lump of meat. There's more to it. It's all the nerves, the synapses, neurons inside, all the electricity, the chemical, everything that makes us who we are. Study of how the nervous system works. Yay, the NSS, the nervous system. Studies which work with the structure of function of the nervous system and brain. Yeah, I think that's a pretty good one. Maybe you Googled it. I don't know, but that's a pretty good definition. That was autocorrect. Should have said it's, and I'm not. Sorry. Don't worry. Honestly, I always making mistakes. So please call me out if you see any today. This is what the dictionary says neuroscience is. Oh, looks a bit confusing. Let's break it down. So it is a branch of neurophysiology. Yeah, you can see I had to put the pronunciation at the top for my benefit, not for yours. And it's a branch of science that deals with the anatomy, so that is the structure, physiology, biochemistry, or molecular biology of nerves and nervous tissues, and especially their relation to behavior and learning. Now, this is quite interesting because it doesn't actually mention the brain, does it? It's just talking about the nerve system, essentially, the tissues, the kind of the connection with inside us. The brain is like the object, but it's what's inside it, which we're really interested about. But it's so wide varying. So let's say here, we've got behavioral neuroscience, why we are the way we are, why do we act, why we do things. And you'll notice there are a lot of different types. And this shows you that this field is massive. Every single one of these, you would expect there to be a separate expertise in it. Like today, we are talking general. So please be mindful. We've got autonomy, what it looks like. What else we got? Neurology, immunology, so many knowledges. Neuroanatomy, health psychology, cognitive neuroscience, evolutionary psychology, imaging. There are so many different branches. So it is a very big subject. So just expectations, today we are taking a very much a wide view of this. However, if you are interested in any particular areas, do let me know and maybe we can do that for next year. First question to all of you lovely people. Has the brain always been known as important? Yes or no? All right. So most of you have said no. Some of you have said yes. You'll notice I didn't do a right or wrong answer for this. This isn't an easy thing to answer. Yes and no. So it has always been a particular thing of interest, even if we're going back to Neolithic times, from the very dawn of humanity, we have always shown interest in it. Have we ever put significant value into it though? No. So it's something like, that's cool, but it might not be the coolest thing ever. So the brain is an interesting one. I think it makes sense because can you feel your brain? Probably not, unless you've got a headache, you're not really feeling your brain. But what do you feel? Your heart feels important. If your heart is beating, you're living, you can see why maybe we put a little bit more emphasis on the heart and we cared less about the brain. Oh, April says ancient Egyptians thought the brain was useless, so they would put it out when mummifying bodies. April, I feel like you've already had a sneaky peek at the presentation. You haven't, but we are going to get onto the Egyptians. Because the Egyptians, they were smarter than they look. I'm not saying they didn't look smart, but they actually knew quite a lot about the brain. They just didn't think it was useful in the afterlife. And that is something that a lot of people get confused by. So let's start off with one of the first things. How do we know we've ever cared about the brain? A thing called trepanation. And this is a hole in the head. A Sugar Babe song or something. Anyway, a hole in the head is annoying. But why would they do it? Why? Because we found skulls and it was purposeful. We're not talking about like a saber-toothed tiger biting into your head or a spear in the head. These are very purposeful operations or surgical positions. And do let me know why you think this may have been done. There are a few schools of thoughts. One, this was the old neuroscience. You're like, okay, person's got head injury or there's a lot of pressure on the skull. Maybe we make a hole, it can relieve it. Another thing, you've got those damn demons in your brain again. Let's get those demons out. For the spirits, it could be religious reasons. It can also help just to observe the brain. And while this seems really barbaric, we definitely don't do this now, people still do this today. And some people say it's new age self-abuse, self-harm, because, oh, I love the way it feels. But some people actually believe it does have medicinal, maybe that's the wrong word, but it does have benefits and it can help relieve pressure. It can help mental health. Now, I'm just going to put it out there. It doesn't. Just because I do not want any of you getting your Black and Decker drill that you get for Christmas, and it's not going to go well. Do not make holes in your brain. But it's interesting that people still believe this. Yeah, let those demons out. You know what? Keep them in bay or just get them out another way. There's more than one way to get those demons out. Oh, I was just about to ask, if it was important, then why would they keep drilling holes in the head? They thought it was doing them good. And there is some evidence to say in some instances, maybe it wasn't all bad. This is 500 BC. No, 5000 BC. So we've been doing this for a long time. You must have been in a real bad way to drill the head. But imagine having mental health challenges that long ago. People wouldn't have a clue what was wrong with you. It was either kill you outright or drill a hole in your head and hope for the best. Let's move on to the Egyptians. Egyptians' mummification ritual. So when they died, they'd wrap them up, send them to the afterlife. What did they get discarded of? A lot of things are like, you know what? Let's keep this. We're going to need this for the future. In the afterlife, we've got to have a kidney, we've got to have a heart, got to have some of those lungs. They're going to be super important. The brain was just like a massive bogey to them. Right, let's get rid of that. And what they did is they'd get like a big metal hook and then wiggle it out and they just get rid of it and discard it. Now, a lot of people think that this is because the Egyptians didn't care for the brain. Not at all. They knew the brain was useful. They just didn't see it being useful in the afterlife because your soul, your part that makes you, is in your heart. And like we've already previously mentioned, it makes a lot of sense because the heart is something you feel. It's beating. It's the brain, unless we are going under the hood and looking, it doesn't really seem to be doing much. But yeah, interesting. But it's just bear in mind, Egyptians didn't not love the brain. They just didn't see it useful for the next stage of life. Now let's go to 400 BC and 200 AD. So this is quite a while. We've got this guy called Galen. He's a Roman Greek doctor. And I think doctor is a bit of a kind word for him. Depending how you look at him, it varies a lot. Okay, now he learned about the body by dissecting animals and treating gladiators. Let's think about it. This ain't so bad. Treating animals, fair enough. Personally, as a vegetarian, I rather not. But I do appreciate that we have learned a lot from animals. And then we've got treating gladiators. So every time let's say they'd have a bad time, they'd get rolled out of the Colosseum and Gladden was allowed to tinker around with them. And sometimes they were going to die anyway. I might as well look inside their brain, cut them up, have a little look around. But you might think that this time period was really barbaric. And maybe in some ways they were, but they did have policies. You were not allowed to just go and dissect anyone willy-nilly. They had to be dying. So there was rules and regulations. This is why predominantly he worked on animals. And if he was lucky, if someone had a bad time at the amphitheater, not the amphitheater, or Colosseum, wherever they were, then he might be able to operate on them. But this brings the wider question. Is it okay to learn from human dissection? Is it okay? Is it not okay? And this has varied over time. Even in London, where I am at the moment, during the Black Plague and Jack the Ripper time, people would often go stealing bodies. They were valuable. Scientists could get enough of these bodies and they'd dig them up to the grave while they had just been buried. And it became a little bit of a massive underground market. So you could say it's not okay because on one hand, you've got to wonder, did he purposely kill people? or were all these bodies ethically sourced? A lot of the time when they were doing the fighting, it was people who were very poor or underprivileged. So you didn't see rich people getting cut up. On the other hand, we have learned so much from this process that we are genuinely benefiting today. I think it's very easy for us to say now, not okay, but we would be in a very different place had we have never done that. But just bear in mind, a lot of this research does come from some human dissections. No photos today, though. Moving a little bit on to 1600, we've got dualism. And this was a more of a thought process or Phrenology, looking at how the brain works. And I just want to know, do you agree or disagree with these different school of thoughts? So just to give you a little definition, dualism says the brain and the body are physical. I think we can both agree that, yeah. It feels quite real to me, but the mind isn't. So the brain and the mind are separate. It isn't and can't be scientifically seen. You cannot see the mind. The idea led to animal experiments helping neuroscientists. And this is quite interesting because the big reason is we cannot operate on people because the mind is sacred. Do not touch the mind. But if the mind is not real, then it doesn't matter. We can slice and dice the human brain. We can stick prods in animal brains. It doesn't matter because we aren't operating on them. We are operating on a physical thing. So that was the key differentiating, is that the brain and our identity are not the same. So we got the brain and body are physical and can be scientifically observed. I think most of us could agree that you can physically see the body, it can be observed. The brain, while you do have to unclip it and take the brain out, it can be observed. The mind is not physical and can't be studied scientifically. Now, this you can see is a little bit controversial, like for everyone. It depends what we call in the mind. I don't know. I think this one is a little bit depending on your viewpoint. It's not physical in some instances, but you can see that psychology exists because we can physically observe how people respond in situations. And in many ways, is that not observing the brain? Then we've got, is ethical to experiment on animals for their physical brains and not consciousness? And let's use animals as in we are also animals. We're not operating on their subconscious. That just isn't going to work. But if we are doing it for physical that part, yeah, it's fine. Oh, Naomi says some people use the metaphor of the brain being the hardware and the mind the software. Yeah, I see that actually working quite well. So on this is saying we can tinker with the hardware, but we can't tinker around with the software. And I would say, yes, you can, can't you? But it's a different skill set. Maybe that kind of applies to this as well. All right. And then we've got some actual literature. Books are being written. Nice. Get your Kindles ready because Autonomy of the Brain, 1664 edition, has been released by Thomas Willis. And this is when we've actually got written down evidence of people looking at reflection. So how the brain and the body works together. We've done that. Move on, reflections. We've got epilepsy. So the first documentation of epilepsy was recorded. And we're suddenly seeing things that have a connection between physical and the brain when they come together. When we talk about the mind, we are obviously talking about mental health. And these things aren't completely separate. They, of course, overlap dramatically. We've also got strokes being observed for some big conditions being discovered. Autism has not been thought about yet. We are getting close. Now we've got a father of microscopy, whatever. That's microscopy. Late in my life. Anyway, this is the study of looking at things under a lens. Before, we only could use our naked eye. But then Anton was like, you know what? I've got this magnifying glass that does 200 times what the human eye can see. This was groundbreaking at the end of the day. So look at these images. Which one do you think shows 200 magnification? Yes, it is the last one. And that is a lot of detail. And look how long ago that was. 1700. That was a long time ago. And we could see that close. This was a game changer for neuroscience because what we're looking at is beyond the human eye can see. We've got Luigi Galvani, he was a massive big deal in the neuroscience community. He was able to show that the brain directly relates to the body. And the way our brains work is via electricity. what is going on here? Our brains have electricity in them. Yes, they do. And this is exactly how he proved it. So I have a little guess here and I'll fill in the blanks. But he discovered that the nervous system uses electricity to communicate. We also know that the brain uses chemicals, but we'll get to that in a minute. So we've got frog experiments demonstrated muscle twitches from electricity. We've got theory, frog legs twitch due to muscles, animal electricity. Galvani exclusively used live frogs. And frog leg studies influenced the invention of the battery. So let's see what we've got here. Yes, no, yes. So frog experiments demonstrated muscle twitches. So what you've got here, you've got yourself a dead frog. This frog was not alive. Yet when you got an electric current and you touched its nervous system, the legs started to twitch. What is happening here? Did we bring this frog from the dead? No, but it does show that our body is a circuit. And when the circuit is complete, movement happens. When it's not complete, no movement happens. You can see how this does relate to a battery, a light bulb. It's the same principle. Even before we were looking into other areas like kind of light, electronics, new technology, we would still realize that our bodies are a circuit. They twitch due to animal electricity. Now, animal electricity sounds odd. That is just electricity inside of us. We have animal electricity. He used dead frogs. Live frogs weren't that useful for this. You can even do this study yourself if you wanted. It's a bit gruesome, but you can, and it does work. And frog legs in batteries. Yep, this was a big deal for neuroscience. Now let's look on to a little bit of literature. Who doesn't love a bit of literature? Who wrote Frankenstein? Actually, one of my most favorite books. The way it's written is beautiful. It was inspired by reanimating dead tissue with electricity. Yay! I'm glad everyone got that right. Mary Shelley. Also a great pub in Bournemouth that I used to drink at a lot. But anyway, yeah, that's not that great, but it was a place I went to. Good old Mary Shelley. So we can see here, we've got here, okay, look, that time period overlaps with this one. Frankenstein was influenced by that day's current fears. We have movies today about AI rising up and killing us. They were no different. They had stories about the dead being reanimated because that is what was happening at that time. Frogs were suddenly moving once they had already been dead. There were experiments trying to bring the dead back to life. This wasn't science fiction. This was actual reality. It wasn't reality to the fact that they were bringing them back from the dead, but it was reality that they were actually trying to do it. Yeah, interesting. Shelley had some great ideas up her sleeve, but they weren't completely original. They were influenced by what was happening in that time period. Now let's look at the 1800s. We are slowly getting up to date. The Bell-Magendie Law is about how different parts of the brain has specific roles. Our brain, it looks like one big lump, but different parts do different things. We already know that the brain and our nervous system is a circuit, but what we didn't know was how this electricity flows in our brain. Can it go both directions or can it only go one direction? And this would be a big deal again. So here's our kind of spinal cord, and here you can see we've got our nerve systems, and it's looking at, does electricity go in one direction or does it go in both? And what we found is it goes in, come on, let's see the answer. It travels two ways a lot. A minute, that doesn't look right to me. No, it travels one way. It's a one-way system. And then it has to go another route in order to get to where it was. So for instance, it will go this way, go that way, and then it has to go back. It doesn't go both ways. And the more we learn, the more we're able to support the brain, manipulate it, understand how neurons work. Because when we talk about brain cells, we've got our neurons, they go one way. Information goes from one to the other. It doesn't go back. And this was the time we learned about it. Now let's look at Darwin. Who doesn't love Darwin? He was like the OG David Attenborough. And he was always observing monkeys and animals, chimpanzees. And he was really interested about facial expressions. So look at this lovely image, looking for a big old smooch. What is this chimpanzee showing? What emotion are they coming across that? We've got love. That's nice. Surprised, romantic. Tell me what you guys do with this monkey. Sorry, Jim. We've got Darwin suggested human emotions, expressions reflect that of animals. So is there a link between our emotions and animals? If there is a link, we aren't so different. And maybe this kind of operating in the brain is wrong. Now, believe it or not, I think that this was shown as potential anger or fight. Come at me, bruh. I don't know, maybe what they do in prisons. But they were showing that there is connections. There were some animals more than others, ones that are more closely related to us. And this obviously reflects in the brain, because if the animal is doing a facial expression in order to show an emotion, that must mean that they have emotions and they do have cognition and their brain is processing. Maybe we have underestimated our furry friends for way too long. And today we know that they are really similar to us. We really should treat them with more respect. Okay, we've got interest, curiosity, amazed. Now, obviously, we are all different viewpoints on what this means. But human being, that we can tell that it is definitely doing an expression. We seem like we were going really well in science, right? Like, we are doing good now. We understand about electricity. We understand how the brain works. And then this came along, phrenology. And this was a bit of a backstep, to be honest. This was essentially like your horoscopes back in the day. Oh, what are you on the Virgo? Oh, what's that lump on your head? Oh, it's just curiosity. It was that the lumps and the bumps on our brain correlate to personality qualities. And this was all the rage. Everyone was doing it. It was like kind of a bit of fun, but also people seriously believed it and paid a lot of money. So as you can see here, the brain is all split up. Now, is there any truth in this? Kinda, because we do know different parts of the brains are predominantly involved in certain processings like sight, vision, cognition. But is one part of the brain related to a personality? No. This was a complete hogwash, gobbledygook, made no sense. And I wasn't the only one who thought so. Also, good old Mark Twain, our lovely Huckleberry Finn friend, thought so as well. So Mark Twain, I don't know if any of you know this about him, hilarious, was right banter at parties. And he was also very inquisitive. Despite its flaws, phrenology did have some interesting elements that expanded our learning, but it was pseudoscience. And Mark Twain, he said he went somewhere and he found a cavity, and he started me by saying that a cavity represented a total absent sense of humor. So Mark Twain went to a phrenologist and they looked at him, but here's the key thing. He went in disguise. I don't know, maybe he had a different mustache or something, and he gave himself a new name. Hello, I'm John Smith. And the person looked at him, looked at his bumps, went, oh, mate, I hate to say this. You aren't funny. You have no humor. Sorry to break it to you. Oh, sorry. And then Mark Twain found this funny because he's hilarious. He's won awards for being funny. He is known throughout the world as being real funny. 3 months later, using his own name, hello, Mark Twain here, got his normal mustache back. And now this cavity wasn't there anymore. And in place was the loftiest bump of humor that this phrenologist has ever encountered. So you see that it doesn't make sense. It doesn't add up. Very much star signs, where, again, I always use as an example, I'm Virgo and I thought I was another one for like most of my life. And I would always read my mum little like TV guide, go to the back. I'm like, oh my God, this is me. And then I realized I was reading the wrong one for years. It's interesting. Good old Mark Twain, always banter. But then moving on, we're on to the 1990 now. Oh, we're finally getting on to modern time. What a decade, eh? Even if I do say so myself. Yes, Mystic Meg. Oh, God. If it wasn't for her, I never would have asked that girl out. It was that time she said, do it now or you'll regret it. I did regret it. Anyway, birth of fMRI. This is machine imagery, which goes and will give a detailed image of the brain. Before this, we were cutting up people. We weren't able to have a look at the brain without it being invasive. On here, what area do you think is responsible for vision? Now, for those of you who put it at the front, it makes sense, right? The eyes are at the front. Surely the brain is thinking at the front. But no, it is the back of the brain. This is where our processor is. Light comes in, goes to the back of the brain, does some magic stuff, and we get our vision. And this was able to be seen because by doing scans, we could see where activation was where things were being stimulated, where the electricity was flowing through. Yay, Naomi remembers going high school psychology. That's good. Yeah, the back of the brain is where the good stuff's happening. The front of the brain is cognition, processing, the middle with like speech. It's worth noting though, that while certain areas of the brain do have a preference, we use the entire brain for everything. We don't have a part of the brain which is just waiting around for us to do something that relates to it. There are just some areas that have higher levels of activation. Is MRI similar to phrenology? Does it relate? Because if you think about it, it seems similar. You're splitting the brain up into sections and you're saying, this is vision, this is language, that's balance, that's feelings. It sounds quite similar. But the difference here is this is based on real science. When we do fMRI scans, we can see that if we are making someone feel an emotion, if they are viewing something engaging, if they are speaking another language, different parts of the brain will show more activeness. So this, while it looks very reminiscent of phrenology, different ball game. So worth noting. The difference is that one was, hey, this seems true. And the other one is, we can prove it's true. Oh, we got, yes, but just because an area is activated doesn't tell us everything. It's correlation, not causation, as they say. You're absolutely right, Naomi. And the game, because when you look at the brain scans, some parts will show other activation. It might be red herrings. And also you could argue that the equipment we're using just isn't sensitive enough because a whole brain is active and we focus on some areas rather than others. I'm not saying it's 100% perfect approach, but that's why we have other methods such as like ERGs, EEGs, CAT scans. There are more methods than just this to look at how the brain is operating, all with their pros and cons. Okay, we're coming up to modern times now, but the more modern we get, the more myths that we believe. What side of the brain controls the right side of the brain? Right side, right brain, you seem to make sense. But now that we're actually looking at the brain and we're able to see that when we're using our left arm, it is the right side of the brain, which is doing the control. And we're able to prove this because like if one person has a brain injury like here, then they might lose access to their mobility on this side. And it's because I'll say cables. The cables in our body cross, as well as our eyes cross as well. So it's why that left side controls right side, controls left side. And this is why you can notice when people get paralyzed, they use mobility on one side rather than the other. Okay, we're almost at modern time now. We're getting there. Let's look at Golgi. Now, I don't know if any of you know of Camilo Golgi and Santiago Ramon y Cajal. I really apologize for the pronunciation, but you can read it hopefully. Have any of you heard of these people? These were pioneers. If you love watching Twitter, like beef on Twitter and watching celebrities fight it out, now this was the OG entertainment. These two hated each other. They were not friends. They were like competing head to head. They had very different ways of understanding the brain and what it was made up of. But this is where it gets interesting. Though they were, I wouldn't say mortal enemies, but they weren't fans of each other. When it came to the Nobel Prize, they both won it because their competition against each other pushed the other one to do their research and they built upon each other. So a really great rivalry. And though they weren't overly happy with the result, having to share it with that geezer, where would we be without them? So Golgi saw the nervous system as continuous networks. Bell believed it was individual neurons. Who was right? Okay, it's interesting what I'm seeing at the moment. It was Santiago Ramon y Cajal. I think the J is like a H in it. Well, work with me here. And Gowdy, do you know what? He was great. He did really great things. So when we look at these images of our brain cells and our neurons, he developed this. We called it like a Golgi stain. And this is when we could like dye parts of the brain and we're able to see the brain cells. This was a big deal and we still use it today. However, he thought it was a continuous thing, like everything's interconnected, like lots of different like roots in one like massive beast, when in fact, they're all individual and they're slightly connecting, but not quite. And you can see that Hal wasn't able to find his correct answer if it wasn't for Golgi. So those two needed each other to get to where we are today. It's a great example of healthy competition. Yay, Nobel Prize. Now, here is some lovely shade. You could definitely imagine this being on their version of Twitter back in the day. Cajal used Golgi stain to show individual cells both got the Nobel Prize. Imagine that you created a groundbreaking technique in order to show the human brain and its cells, and yet your enemy or your frenemy used your own technique in order to solve the problem that you wanted to solve before you. A really fun time in history. And he had this to say, Cal, is what a cruel irony of fate to pair. Siamese twins united by the shoulders, scientific adversaries of such contrasting character. That's quite graphic, right? It's like, I've hated it. So I think this quote, you get the relationship. Let's go to a little bit more modern time now. I remember how originally I spoke about where is the brain? Is it purely this thing up top? Or does it count as our nervous system and stem as well? So what I want you to do here is rank in terms of processing complexity. What part of our brain is the oldest and what part is the newest? What part there is more going on and which part is not really pulling its weight? We have found that all parts of the brain, there is a hierarchy. So yes, okay, interesting. Now the spinal cord, or see this bottom bit here, and it goes down there. The brain stem is the kind of connecting bit, and forebrain there. Now, I thought the forebrain was more important because that is the part that's doing it, and you can see it goes down. Information kind of travels downwards. And the spinal cord is actually one of the earliest parts. The brain stem, really old, and the forebrain is something that developed later on. And you'll notice that animals that are less advanced than us will have, say, spinal cord, or they'll have a brain stem. And the more advanced ones will have a forebrain. And that's one of the ways we're able to know. Remember how I spoke about how our brain has electricity inside it? It also has chemicals inside it. But we didn't know that until relatively recently, actually. In 1921, Otto had did this experiment and he showed that our nerves use chemicals to communicate. And I think this is pretty cool. So we've got two frogs, right? One with nerves, one without. So one frog has got its nerves, one frog doesn't have its nerves. Then we've got simulated nerves. Heart, one. So in a kind of fake nerve, the heart slowed and okay, actually, you know what? That's complicated, but what I will say is we had the heart and we put some simulated nerves in it. And when we applied like a chemical, we'll notice that we started to see reactions. So you used to see that the heart was reacting to the chemical. One that was connected and one was with not. So by doing a little bit of show and tell, again with frogs, we have a lot to thank frogs for. We were able to prove that our bodies are regulated by chemicals. So big move this was. And as you can see, this is what it looks like now. So this experiment revealed that connections weren't just electrical, but chemical, and coined the word synapse. Woo! It took to like the 20s in order to find out what a synapse was. So as you can see, you've got your neuron here. And at the end of the neuron, you've got your synapse. And all this, okay, let's do this part because it's easier. Here, this is where electricity flows. And the electricity flows. And when it gets to the end of these, which we call dendrites, when it goes to the next synapse, so dendrite goes to the next one, that is when it uses chemicals. So we are talking really small here, and you can see why it took a long time in order to figure this out. Because while we were able to stain these and we're able to see that they exist, we weren't able to see this chemical reaction and transfer. Now, just to top all this off, what are some recent neuroscience milestones we are still developing now more than ever? In 1963, Hopkins win Nobel Prize for neurocommunication, understanding that how our brain is a network. While they are individual cells in our brains, they are all connected in the sense that it's one big unit that sends information all over. 1970s, 40,000 strong Society for Neuroscience.
It originates from American Physiological Society.
Yes. Okay, thanks. For those of you who are new, I do know what I'm talking about. I swear I'm just heavily dyslexic. Well, I'm sorry. So we can see that people are growing. Scientists are actively studying the brain now. Now, in the 80s, this was a really big deal. The Human Genome Project was project was planned. And if you don't know what this was, understanding our DNA. In the early 90s, President Bush declared the decade of the brain. This means there was a lot of money put into neuroscience, and even governments were realizing that this is important and this is the future. We have fMRI brain scans. So now we are having a really detailed map of activity and what areas are related to what part. Obama launched the Brain Initiative So we're getting a big thing here. Before, it was a couple people on the fringe of society. Now, even presidents are saying this is an area which needs investment and needs focus. But the future is looking really interesting. And we spoke a little bit about the future in previous webinars. But on this, what are you most excited about? The future of neuroscience. So CRISPR, for those who do not know, this is when we can actually edit our DNA. Slicey dicey, like maybe, got a bit of cancer, not happy with that. Let's snip, let's take that away. Or even, autism. Or maybe, I think it's controversial, but it's very interesting. Or we got genetics, where we're able to control the brain. So for here, we're using a laser in order to rewire the brain. Maybe if someone has epilepsy, schizophrenia, we're able to control the brain via lasers. We've got neuroprosthetics. So if you lose your leg or an arm, we're able to connect a cyborg, essentially a robotic leg, and you'll be able to move it as if you had your real leg. So it actually works the same. And we also got computational neuroscience, being able to have an accurate model of the brain in a computer. If we had that, we could do so many things. Our brain is ridiculously complex. We do not have a computer which can mimic the brain at the moment. But we're not that far off. So the future is really interesting. Now, just to do a quick summary of what we covered, obviously there was a lot more to the history than what we possibly could have covered today. But we spoke about how neuroscience is spanning cellular to cognitive areas. So it is more than just the brain. We spoke about trepanation. So essentially, people have known about the brain for a long time, even if they were a little bit off the mark. We know that the brain has been useful in terms of rituals and understanding knowledge. So again, the Egyptians may have known that it was useful for knowledge. They just didn't think it was useful for the afterlife. We learned about mysticism and how people use that as pseudoscience. We learned that the brain has shaped our lives and mechanisms. We've been looking about the difference between brain and the mind, mental health and physical health. Early life, we've learned about rivalries, different parts of the brain that we will have and how we plan to go for the future. If you thought this was really interesting, Matt, and you know what? You only touched the tip of the iceberg. I agree with you. And some books that I'd recommend is Soul Made Flesh by Carl Zimmer. A really cool book. This is how the secrets of the brain were uncovered in 17th century England. While today we did everything, this is narrowing down onto one part of time, but this was a really interesting part of time. Gruesome, bloody, disgusting, but where would we be without it? Another book is by Oliver Sacks, and this is The Man Who Mistook His Wife for a Hat. And this is talking about how we understood mental health. And it seems a bit silly at first, but actually you realize an observation can teach us a lot about it. So how the birth of psychology and how it links up with neuroscience. Some great websites is the History of Neuroscience by the Society of Neuroscience. The website looks a bit dated, but you know what? It has some interesting information and I got a lot of it from today's webinar. If any of you are in London or visit London, I highly recommend the Wellcome Collection. It's my favorite museum in London. They have lots of bits of bodies and brains that you can explore and look in tubes. It's very tactile, you can touch things. And they have a lot of books on psychology as well, which is just genuinely really interesting. It's right outside Euston. I recommend it if you go. We've also got the Natural Museum of Health and Medicine in the USA. Help me if I don't know what part of the USA that is in. I haven't been, so I can't personally recommend that one, but I just thought not everyone's in London. And in terms of journals, these are academic papers. So I'll be honest with you, they're not the easiest read, but still good to go. We've got the Journal of History of Neuroscience, and you'll find loads of really great up-to-date studies on the brain. And you can see here all the latest ones, what's been publishing, what is currently being learned about the brain. Highly recommend. Now, the next webinar, gene editing. You know how we spoke about CRISPR? We're like, most of you, look, I'm going to quote all of you. Most of you said you were most interested about CRISPR. Let's look into it. Next week, how can we have our DNA, which is who we are, and cut it up? When we talk about how this relates to autism, I think it's really interesting because we often talk about how autism isn't something you carry like a handbag. It is essentially part of who you are as a person. But if we can cut that part out of you, what does that even mean for neurodiversity? Is this a contradiction? Is this a positive thing? If we want to get rid of the disease, amazing. But if you want to change your personality, maybe not so much. Could this be used for good? And could it even be used for evil? We are going to be taking a look at the future of neurodiversity. Can we really live in a world which embraces neurodiversity if we're willing to edit it out of our gene pool? We'll see. And the last slide, fingers crossed. Oh no, one more. Here's our YouTube channel if you want to sign up and if you want to see today. As you can see, we've got Metacognition. We've also got a lot of other new ones today. What's the other new one we got? Actually, I think the other one we're going to be re-uploading again soon. But all neuroimaging, do check them out. And again, thanks to April for all the hard work she does. And do drop us an email if you have any questions. Okay, quick questions. What is Asperger's genetic? We don't use the term Asperger's anymore since 2013, but it is genetic. Autism is genetic, runs in the family. Okay, thank you everyone. And hopefully I'll see you next week. A pleasure as always. And thanks for putting up with my terrible pronunciation. But I hope that you were able to learn a thing or two. Bye everyone.